This is page 43, and this one can be a little bit intimidating, but you know how to do these. They just look worse than they are, in my opinion. The first thing I want us to do, though, is over here to the side, I wasn't real clear. We're going to find the missing angles. So we have V, W, X, Y, and Z. So I want to go ahead over here and list those out. W, sorry, I'm going backwards. Angle V, W, X, angle Y, and angle Z. So we want to know what the measurements are for each of those. And they're all jumbled up here in this big old triangle. So I actually see 4 triangles here. I see the composite triangle that has 3 smaller triangles inside. And I'm going to start with those 3 smaller ones. So let me color in this first one. And I've used yellow. You can use whatever color you want. You don't even have to color it. But it really helps me to see the colors. So I can see that angle W is in there. It's part of this yellow triangle. And we can find angle W simply by saying the whole triangle, the yellow part, has 180 degrees. I have 132 plus 31 already in use. So I'm saying 180 minus 163. Use the calculator if you need it. I believe it's 17, but I don't trust myself. I cannot subtract in my head very well. And yes, that is correct. Okay. So angle W right there is 17 degrees. And I'm going to come over here and go ahead and put that in. So we found one piece of the puzzle. All right, so then let's color the next triangle. I'm going to use orange. Again, you don't even have to color it. It just helps break this composite shape up into smaller shapes, which we have to do in order to get what we need. But this one has 2 unknowns. It has the Z and it has the V. So we're going to have to figure out both of those. Just subtracting from 180 won't work this time. We could take the 122 from 180, but we have 2 angles left. So for this one, I'm going to use the half circle trick. I'm going to say, okay, these 2 angles, pretend that's a half circle. Let me not even do that because that looks wonky. Let me just draw a half circle. You see that? So V and 132 make half a circle. They're supplementary because they're on a straight line. So I'm just going to say the 180 in a straight line minus the 132, and that's going to give me V. That would be, I think, 48, but let me be sure. 180 minus 132, yes. So angle V is 48. Let's go ahead and put that one over here. And then once you know angle V, you can find angle Z. Because angle Z is going to be 180 minus 122 plus that 48 that we just found. This is V. This is Z. So 180 minus the sum of those. Be careful. It's very easy to want to subtract them. So there's 170. Is that right? I guess it is. Looks right. So the difference there's 10. I'm going to check that. I don't like the looks of it. 122 plus 48 is 170. Okay. So angle Z is 10 degrees. So we're getting there. Last but not least, I'm going to color this one blue, and we will find the remaining 2 angles. Now it does have 2, so you can't just subtract from 180 and be done. But I do recognize that X is supplementary to 122, and I'm going to use that in my favor right there. So 180, this is for X. The supplements will add up to 180, so 180 minus 122 is 58. Let's double check. I can't even type it in my calculator. Yes, 58. So that's angle X. And then finally we can finish it because we know X and we know 43. So I'm going to put that right over here. We're looking for Y. So we have 180 in the triangle minus the 43 plus the 58. So 180 minus 81. No, that can't be right. 43 plus 58 is 101. And 180 minus 101 is 79. So Y is 79 degrees. So this is really more of a reasoning problem. The math is pretty basic. It's just subtracting and adding. And with the calculator, it's even more basic. But you have to really be able to reason yourself through there. And that's what they're testing if you get one of these problems. All right, the next one. We have an isosceles triangle. So I'm going to come right over here and draw it. Remember, isosceles means that it has 2 congruent or equal sides. That would be this one and this one. And then that means that the 2 base angles are also congruent. So this angle and this angle will be equal because those 2 sides are equal. And of course, this is called the vertex angle. These are each called the base angles. An isosceles triangle has a base angle that measures 74 degrees. Well, if that one measures 74, that one measures 74. What is the measurement of the vertex angle? So we know that the whole triangle has 180 degrees. 74 on one base angle, 74 on the other. So 180 minus the sum of those 2. 180 minus 148 equals 32. So that means that that vertex angle up here that we are so interested in, right here, is 32 degrees. And that looks pretty accurate. My drawing is not to scale, but it's pretty close, I'd say. Okay, the next one. A right isosceles triangle. Be careful there. This is a very specific kind of triangle. It is a right triangle. And when they say isosceles, they're simply telling me that this situation, there's the right angle, that this leg and this leg are exactly the same length. A right isosceles triangle has one angle that measures 45 degrees. So let's put the hypotenuse on here. And we know that one can't be the one that's 45 because it's 90. Okay, so if that one measures 45, what is the length of the other angle? Well, we know this one is 90. They told us that this one is 45. And if it's an isosceles, I know that this is 45. It has to be. The base angles are equal. But mathematically, we can prove it as well. The whole triangle has 180 degrees minus 45 degrees plus the 90 that's in the right angle. So we have 180 minus 45 plus 90. That's 135. And that should give us the difference of 45 degrees. But if you know the vocabulary, you don't even have to work that one. You just know it has to be 45. All right. A flagpole casts a 20-foot shadow. So I'm going to draw myself a picture. You can draw yourself one. A flagpole is a very tall, skinny cylinder. So there's the flagpole. And the shadow on this thing is 20 feet. So let's put that in. Always ask yourself, where's the sun in this picture? So it would have to be on this side if my shadow is going that way. But it's worth asking yourself that. Sometimes I've seen problems where that actually mattered. But this one, it doesn't. It's just good to know. Okay, so the sun's shining, the flagpole's casting the shadow. At the same time, a yardstick casts a 4-foot shadow. So we have a stick over here, but it's a yardstick that's casting a 4-foot shadow. So the foot, 4 feet, that works. But I don't want to put yard in here. My units always need to be the same. So I'm going to convert that yard into its feet equivalent. And a yard is the equivalent of 3 feet. And they want me to find how tall is the flagpole. They want me to find the height of the flagpole. So this can be done with the similar triangle rule using a proportion, where you have the height compared to the shadow, and the flagpole, we don't know the height yet, but we know its shadow, I can measure with a measuring tape, is 20 feet. We know that that's proportionate to the height of the yardstick, which is 3 feet, and its shadow, which is 4. And once you have those numbers in place, you're good to go. 20 times 3. You always multiply the peanut and then divide by the number that's not in the peanut. And that gives you a height of the flagpole of about 15 feet. That is a very good math problem. I have never taken a math test that didn't have one of those.